Hi guys, imagine that you have internet gateway failure and you need to immediately set up the other internet gateway with the same exact ingress and egress gateway policy, and you still rely on manual script template in provisioning your network. How fast will it be? In this video, I'm gonna explain and demonstrate automated gateway policy motion with Cisco Peering Fabric Network Automation, which comprises of Cisco Peering Platform, Cisco Segment Routing, and Cisco NSO, Network Service Orchestrator. And you can check yourself how fast and agile the network automation helps in this failure situation. It can also help during the network migration or day 2 operation. This video is part of Cisco Peering Fabric demo series, and my name is Hinwoto. I'm a Cisco Technical Solution Architect, a CCIE, and a CCDE. You can get more information of Peering Fabric Network Automation. Please sign up to ciscolive.com and access to the Cisco Live session, Intelligent Peering Fabric Network Automation Use Cases. There are complete slide deck and demonstration video.
Now, in this use case, I will use the REST API client Postman to configure altogether all the policy, ingress policy, incoming policy, which is the priority list here. And then for certain customer prefix, ID cloud -2 on router 4, Internet Gateway 4, as well as the outgoing policy egress in one go using the Postman REST API client here. And here we can see that the outgoing policy for Google through OS 6, YouTube through OS-1, all together using REST API rather than we click it one by one. And then the motion of the gateway policy happens when the gateway 4 fails. Maybe it's a site failure, link failure, or router failure. So we want to have a very immediate router take over this function. In this case, this is a router 2, and we will swing all the policy, all the gateway policy that automatically to the router 2 here. So we router 2 will have the same incoming ingress policy and outgoing egress policy, same as the previous router form. Very fast, very simple, very easy way to the NSO. This is the idea. Let's see the demo here. Okay, first, let's clean up all the Internet Gateway service first. You can see here, I have cleaned, I have deleted all the previous Internet Gateway service. Then I will use REST API client. This is the REST API client. I have prepared this REST API post. Yeah. Here I have prepared. Let's say that we have the virtual gateway for our customer enterprise A. That this customer would like to have very specific ingress policy, right, with the priority list there, and also the outgoing egress policy for the Google through what? Through low latency here. You can read it in a JSON format. We can prepare it in advance with the policy. This is a very simple way. We can use the web portal that create this value, JSON value. Okay, and then this is the IP address of the NSO. We will send it through to the post call of the REST API. I'm sending now. Let's see of the result here. And before that, no internet gateway service here for a while. Sending from REST API call to the NSO, which is the IP address with the HTTP post with the REST payload there. Okay. So once it's sent to the NSO will right away also push or configure the network element, the router right away. 201 looks good. Yeah, it means it's successful. And then we refresh here, and I see that I have the customer A filter gateway peering service here. Let's take a look inside. This is all the policy already configured in the JSON format before, already configured here. It applies on the router 4. We define the low latency peer, static, and cost. We advertise the ID cloud 1, 2, and we define our egress outgoing policy here. Now, looks good. Let's verify it one way on the router 4, which is the router 4 now, right? So let's verify outgoing here. It's T1, Google. So Google. So from 4, it will go to 3, 7, 6, and 5 again. Okay, that exactly. Now, to simulate the failure, I will use Python script that I will shut the node 4 here, node 4 down, right? Actually, I shut down all the node 4 interface. And node 4 will stop advertising the customer premise. Then we need to immediately configure a new router with the same exact advertisement policy, incoming policy, and outgoing policy. Let's do so. First, I will show this action. We have option undeploy. Undeploy means that NSO will undo all this policy on the selected node, which is node 4. We will undo all it, detach all the policy first. Okay. The ball is rolling. NSO is detach all the policy from node 4 perspective, and so that we can configure new node on this set of policy. Okay, true. And then next, I will, okay, let's simplify this. Next, back to the customer A filter gateway. And later, okay, let's hide again, simplify the view. Later, we change the gateway here to node 2. That simple click already swing all the policy to node 2. Of course, the node 2 should be ready in terms of the day 0 and day 1. We configure the day 2 operation here, right? So here, you can see we can, let's check on the router 2 first. Assume that router 2 show run BGP. Make sure that there is nothing BGP advertisement there. No, right? Nothing, right? That's good. Then let's go for it. Okay, the ball is rolling now. We start configuring router 2 with the same policy exact as the previous router, the failed router 4. Okay, let's check it again on router 2 here. So run router BGP. Now we have it. Let's verify whether router 5 already received our advertisement before we do the trace route. Okay, he got it. Now we can do the trace route like we did Google to verify we have the same exact policy there.
This meeting is being recorded.
Okay, let's verify it again from the router 2 towards the Google again, like before. So here, Google. So it goes to 3 and then goes to 7, and then 3, 7, 6, and 5, and then you select the low latency peering here, 7 and 6 correctly. So we have the same exact policy as before. So this is the gateway policy motion. Right. So I hope you guys can follow the demonstration and really see the benefit of this intelligent peering fabric automation. So I like you guys to have the key takeaway. We have addressed and we have built our automation to solve all these peering use cases. The ingress peering automation, the incoming based on low latency, based on low cost, based on telemetry, right? And also the egress, the outgoing, the outbound automation based on this parameter all together. As well as we can have the inbound, the ingress, and the egress outbound resiliency with prioritization. Very simple manner. Just a matter of click and define it on the NSO or through a REST API for all-together policy. And we also can leverage NSO capability to automate the gateway policy motion in case you want to swing from one gateway to another gateway for the policy. And we can have the very specific destination policy, as well as it's very scalable. We can start from our integrated standalone internet gateway to our distributed peering fabric. So the peering fabric solution that I have just demonstrated is consists of this network design, our Cisco Peering Fabric Platform, iOS XR is the key, and Cisco iOS XR telemetry as well. We can combine with the crosswalk or open source telemetry stack. The segment routing is the very key factor here. You can see here. It's very flexible, very granular, and very simple to configure, as well as the ODN, on-demand XOP, and path computation element, and of course, our main automation software, NSO, Network Service Orchestrator. Okay, so it is the Ferrite design. It's very reliable. It can be very scalable, can be very granular, telemetry based, and very fast. You can see I have done all the use cases within this less than 2 hours, I can say so now. Very faster time to revenue. We can optimize our peering utilization, and of course, most importantly, we can improve our customer internet service experience. So I like to record this Jack Wells quotation. I think very good. Control your own destiny, or someone else will. In our case, control your own multi-cloud and peering traffic, or something, or someone else will. That's from the Peering Fabric Network Automation. So this is the additional peering resources you can revert to. Please take a look. It's very good document, very well documented, and a lot of resource. I love this all blogs and the segment routing resource. Very good books from Clarence and Chris, which are segment routing books part 1 and 2. Looking forward to part 3 for the SR physics, as I know. And yes, please check my YouTube channel as well. I have recorded some segment routing use cases as well as with the segment routing policy or path comprises element and NSO in terms of the transport and VPN service and architecture of transport as well. I think later on I will add more video recorded there. And also the segment routing channel on the YouTube. Yeah, that's very good. I think, hope you get very useful this session. Thank you. Feel free to reach me for any update or for any concern. Thank you very much.